Hi everybody, hope you're having a wonderful day. Today we're going to talk about limiting reactants, also known as limiting reagents. So limiting reactants or limiting reagents. Limiting reactants are reactants that run out first. So sometimes you have multiple reactants reacting together. So let's say you have two reactants, for example. Maybe you measured them exactly so that they both get used up at the same time. But most of the time, that's not the case. Sometimes there's one reactant that runs out, and then there's a little bit of leftover reactant in the other one. And so a limiting reactant is the reactant that runs out first. It's not necessarily the one that you have less of, so not necessarily less moles or less grams, but it's the one that runs out first. So you just saw in your demo with the s'mores that the chocolate ran out first, and so it limited the amount of s'mores that you can make, and so we say that the chocolate is your limiting reactant. And so let's take a look at this example here. We have magnesium reacting with oxygen. So let's write out our product. This is synthesis. So magnesium and oxygen will combine to make magnesium oxide. Magnesium is 2 plus, oxide is 2 minus, so MgO. And to balance it, we'd need 2 of these and 2 of these. So right here, I have an example. I'm given 4 moles of the magnesium, and I have 3 moles of the O2s. And right here are the 3 moles, and here are the 4 moles. So the idea is that this side needs to equal to this side because mass is conserved. So the same number of atoms should be here, and here they're just rearranged. This was supposed to be a MIMU activity, so you're supposed to be able to move these up there to put them in your beaker and rearrange them. But, unfortunately we can't do that today. So we're just going to draw it out here. So I have an Mg with an O bonded together. So I used up one of these and one of these. Let's make another one. Here's another magnesium and an oxygen. So we used one of these and one of these. Let's make another one. Magnesium and an oxygen. So here's this one and this one. And then another one. And you keep going until, one of your reactants runs out. So now we use this one and this one. And now our magnesium, now our magnesium is all used up, but we have extra oxygen that we didn't use. So this oxygen is basically left over still as O2, but my magnesium ran out. So what is my limiting reactant in this case? My limiting reactant would be magnesium because it ran out first, even though I had more of it. I had 4 moles of magnesium and only 3 moles of oxygen, but yet magnesium was my limiting reactant because it ran out first. I have extra of the O2. Okay, how many moles of product did we form? So let's look at this. We have 1, 2, 3, 4 MgOs. So 4 moles is our answer. 4 moles of MgO. How much of the excess reactant will react? So magnesium is my limiting reactant. That's the one that runs out first. So oxygen is what we call the excess reactant. We have too much of it. So how much of the excess reactant, how much of the oxygen reacted? So if you look at this right here, we used up 2 moles of the oxygen and 1 was left over. So 2 moles of O2 reacted, 1 mole of O2 was left over. Okay, let's try another one. So we have 3 moles of phosphorus. Here are my 3 moles. Are mixed with 6 moles of sodium. So here are my 6 moles. So first you want to write out your chemical equation. So let's do that. So we have phosphorus plus sodium. So that's also synthesis. It's going to form sodium phosphide, which is ionic. So sodium is +1, phosphide is -3. So Na3P. Let's balance it. So we need 3 sodiums for every phosphorus. So again, on this side, the number of atoms should be the same as this side. So here are my 6 sodiums, here are my 3 phosphoruses. And again, I was supposed to move these, but unfortunately I can't right now. So I'm just going to redraw them. So looks like for every phosphorus here, we have 3 sodiums attached to it. So my product is going to be a phosphorus and then 3 sodiums around it. So I used up a phosphorus and then 3 of the sodiums. We have enough to make another one, so here's a phosphorus, and then here's 1, 2, 3 sodiums. So I used another phosphorus and then 3 sodiums, and so it looks like I have 1 phosphorus left over here. So what is my limiting reactant in this case? Looks like the one that ran out first is my sodium. So again, even though I have 6 sodiums and only 3 phosphoruses, the sodium still ran out first, so that would be my limiting reactant. Okay, how many moles of product will form? So let's look here. I got 2 moles of the Na3P, so that's 2 moles of Na3P. Next it says how much of the excess reactant will react and how much of the excess reactant is left over. So first of all, if sodium is my limiting reactant, that means phosphorus is my excess reactant. So my excess reactant, which is the phosphorus, looks like we used up 2 moles of it. Those reacted. And then 1 is left over. So 2 moles excuse me, of phosphorus reacted and 1 mole of phosphorus is left over. On your test, you will have questions like these with pictures, and you actually have to draw your products like this and figure out the limiting reactant by drawing pictures or particle diagrams. So make sure that you review that before your test. Okay, let's try another problem. This one doesn't have particle diagrams. It says consider the combustion of propanol, which is C3H7OH. We want to identify the limiting reactant if 4.3 moles of oxygen react with 2.1 moles of propanol. So as always, this seems like a complicated question, but it's talking about a chemical reaction, a combustion of propanol. So the first thing you always want to do is write out your reaction and balance it. So let's do that. So we got C3H7OH. It says combustion. We're burning, so that means we're adding O2. The products of combustion of a hydrocarbon are always CO2 and H2O. And let's balance our reaction. So we'll need 2, 7, 4, and 8, and that's balanced. All right, I like to write down what I have. So I know I have 4.3 moles of oxygen, so I'm going to put 4.3 moles here. I also have 2.1 moles of propanol here. And I'm asked, which one is my limiting reactant? Which one runs out first? There are 2 ways, excuse me, that you could do that. The first way, so, if I wanted to know the s'mores, which one is my limiting reactant? Is it the graham crackers, the chocolate, or the marshmallows? One way is I could start making s'mores and keep making them and see how many I could make with the graham crackers, see how many I could make with the marshmallows, and see how many I could make with the chocolate. And whichever is limiting me, whichever is making the least amount of s'mores, would be the one that's limiting. So what I could do in this case is I could start with this, see how much product I would form. You can pick whichever product you want, it doesn't really matter. So let's say CO2. So I could pick propanol, start with 2.1 moles, and see how much CO2 would form. Then I would start with the O2, see how much CO2 would form. Whichever gives me the least amount of CO2 is the one that runs out first, so that's my limiting reactant. The other way that you could do it is you could say, well, okay, if I have, let's say, 50-gram crackers, I would need 25 chocolates. And then I look, do I have 25 chocolates or not? So I could figure out what I need and see if I have enough available or not. So you could start with one of your reactants. It doesn't matter which one. Let's say you start with propanol. You would solve for how much oxygen would be needed, and you would check if the needed amount to react with the propanol is available or not. So we're going to do both ways in our notes. So let's start with the second way for this one, because it's a little bit less work for this specific one. In other cases, you know, the first way would be less work, and you'll see. But either way is perfectly fine. So let's start with the way where you take one of your reactants, solve for how much you need of the other one. And again, it doesn't matter which one you start with. Let's go with propanol. So write down what you have for the propanol. We have 2.1 moles of the propanol, C3H7OH. I'm going to do a conversion factor. On the bottom, I'm going to put moles of propanol. On top, I'm going to put moles of my other reactant. And since I'm given moles here, then I want to end up with moles so I can compare the two numbers. If I were given grams, then I'd continue and go to grams. So you need both of these to be the same unit so that you would compare them. All right, so to compare between moles of propanol and moles of oxygen, you use your stoichiometric ratio. So there's a 7 in front of the O2. There's a 2 in front of the propanol. So that gives me 7.3 moles of O2. Whenever you do it that way, always write the word needed after. So what does that mean? That means if I use up all of my propanol, I would need 7.3 moles of oxygen to react with it. So do I have enough oxygen to react with my propanol? Do I have 7.3? Nope, I only have 4.3. So I don't have enough oxygen. That means oxygen is limiting me. So therefore, this is need more than available, or have less than needed, whichever way you want to look at it. We need 7.3 moles, but we have 4.3 moles. So that means that O2 is the limiting reactant. And that's my answer. Okay, let's say my value, if I had calculated, let's say if this number was 2 moles. So let's say I need 2.3 moles. In that case, would I have enough? Yes, I have plenty. So that means the other one would be limiting me. Okay, let's try another one. It says identify the limiting reactant when 1.7 grams of sodium react with 8.2 grams of chlorine gas to produce sodium chloride. Again, the first thing you would want to do is write out your reaction. So let's do that. So I have sodium reacting with chlorine to form NaCl. To balance, you need 2 and 2. All right, I'm going to write down what I have. I have 1.7 grams of sodium, and I have 8.2 grams of chlorine. All right, I'm trying to find which one is my limiting reactant. So let's do it the same way. I'm going to start with one reactant and solve for how much I need of the other one. So it doesn't matter which one you start with. You can start with your sodium or with your chlorine. I'll start with the first one, the sodium. So I'm going to say I have 1.7 grams of sodium. And to link between two substances, I have to go to moles. If you look at your mole chart, I want to end up with grams of chlorine so I can compare it to this number. So first, I'm going to go from grams of sodium, so grams of sodium on the bottom, to moles of sodium. 1 mole is 23.0 grams. Then I'm going to go from moles of sodium to moles of the substance I want, which is a chlorine. And it's a 1 to 2 ratio for my coefficients. Then finally, because this number is in grams, I'm going to go from moles of chlorine to grams of chlorine. Watch out that that's Cl2, not just Cl, so you need to double the molar mass of a Cl. So 71.0 grams per 1 mole. You punch that into your calculator. You get 2.62 grams of Cl2 needed. Always write needed at the end. So whenever you start with one of your reactants, solve for the other reactant, write the word needed. So what does that mean? This means that if I use up all of my sodium, I would need 2.62 grams of chlorine to react with it. Do I have enough? I need 2.62. I have available 8.2 grams. Do I have enough? Yes, I do. I have plenty of chlorine. That means chlorine is not limiting me. So that means that sodium is the one that is limiting me. So, enough Cl2 available, more than I need, and so that means sodium is the limiting reactant. Let's try the next one. It says what mass of lead 2 iodide will be produced when 16.4 grams of lead 2 nitrate is added to 28.5 grams of sodium iodide. Again, sounds like a long problem. First thing you do, since it's a reaction, is write out your chemical equation. So, what mass of lead 2 iodide will be produced? So, lead 2 iodide, that's Pb2 plus. We got I minus, so PbI2. It says produced, so that's a product. Along with, will be produced when 16.4 grams of lead 2 nitrate. So lead 2 nitrate is Pb2 plus with NO3 minus. So that is PbNO3 2. So lead 2 nitrate is added to sodium iodide. So Na plus with I minus. And so that would be NaI. Now it stops. That's all it says. But you guys are expert chemists. You know that can't be it, because where's the nitrogen? Where's the oxygen? You know, they can't just disappear from the reaction. And so you know that this is a double replacement reaction because you have two compounds there. And so you know that you put the two outer ones together to form the PbI2, and then you put the two middle ones together to form sodium nitrate. And so the other product would be sodium nitrate, so Na plus NO3 minus, so that's NaNO3. Let's balance it. We'd need 1, 2, 1, 2. Perfect. All right, we're given 16.4 grams of lead 2 nitrate. We're also given 28.5 grams of sodium iodide. We're asked what mass of lead 2 iodide will be formed. All right, that seems pretty simple. Seems very similar to problems we've done before. Well, you know, you're looking for grams of one substance. So typically you start with your reactant and then do a grams to grams problem, you know, 3-step problem, grams of A to grams of B, regular stoic. Now, the problem is usually you're given only one number for the reactants. So you use that, you start with that reactant, and you solve for the product. In this case, you're given two numbers. You're given the two reactants. So which one do you use? And does it matter? Well, let me ask you this. If you wanted to figure out how many s'mores you could make, would you start with the number of graham crackers? Would you start with the number of marshmallows? Would you start with the number of chocolate? Does it matter? Can you just pick one of them? Well, it kind of matters. Your limiting reactant is the one that will limit the production of your product. And so you can only make as many s'mores as you could make with the chocolate, because then the chocolate runs out and you can't make any more s'mores. So if you want to figure out your product, you have to use your limiting reactant. So this is actually a two-step problem. You have to figure out first which of these two is your limiting reactant, and whichever is limiting you, that's the one that you use to figure out how much product you form. Okay, so let's do it the way that we've done it before. So start with one of your reactants, and let's solve for how much of your other reactants you'd need. So we can figure out which one's limiting, and then we can solve for the product. So let's do that. So it doesn't matter which one you start with. Let's start with the PbNO3 We got 16.4 grams of PbNO3 So we're going to change that to moles. So 1 mole of PbNO3 on top. On the bottom, molar mass of PbNO3 is 331.2 grams of PbNO3 And then we're going to go for moles of PbNO3 2 moles of my other reactant, which is NaI. And that's a 2-to-1 ratio. And then finally, we're going to go for moles of NaI, 2 grams of NaI. 1 mole of NaI is 149.9 grams. You go ahead and calculate that. You end up with 14.8 grams of NaI needed. All right? So I need 14.8 grams of NaI. Do I have enough NaI? Yes, I do. I only need 14.8. I have 28.5. So I have plenty of NaI. So that means that my lead nitrate, that's my limiting reactant. I'll use Lr for a limiting reactant. So that means that PbNO3 is the one that runs out first. It's the one that limits how much product I form. So that's the one that you use to figure out your product. So now that I know that this is limiting me, I use this to calculate how much product I need, or I would form. So let's do that. I got 16.4 grams of PbNO3 Change that to moles. So grams of PbNO3 on the bottom, moles of PbNO3 on top. 1 mole we said is 331.2 grams. Then I'm going to go from moles of PbNO3 to moles of the substance that I want, which in this case I'm trying to solve my question, which is PbI2 here. It's a 1-to-1. Then finally, moles of PbI2 on the bottom, grams of PbI2 on top. 1 mole of PbI2 is 461.0 grams of PbI2. You calculate that. the answer ends up being 22.8 grams of PbI2. And that's my answer. So, whenever you're given both reactants, you figure out which one's your limiting reactant first, and then you use that to solve for your product. All right, let's try the last problem. So the last problem says we have 2.6 grams of hydrogen. They react with 10.2 grams of oxygen. We want to know what mass of water will be produced. First thing you do, write out your reaction. So let's do that. All right, so hydrogen, that's H2, reacting with oxygen, which is O2, to form H2O. Need to balance it, so 2, 1, 2. I have 2.6 grams of hydrogen. I have 10.2 grams of oxygen, and I'm trying to find the mass of my water. So, since I have two values for my reactants, I need to figure out which one is limiting me, and that's the one that I use to figure out how much product I form. Alright, so like before we figure out which one is limiting me, let me try the other way that I told you about. So far we've been picking one reactant, solving for the other reactant, see if we have enough or not. Let's try the other one. Maybe some people would like the other way better. The other way is to start with this one, solve for how much product you form. Start with this one, see how much product you form. Whichever gives you the least amount of product, that's your limiting reactant. In this case, both ways are just the same amount of work. So it really is just personal preference. We'll do the second way just so that you have it, in your notes there. All right, so let's start with H2. We have 2.6 grams of H2. Let's convert that to moles. So grams of H2 on the bottom, moles of H2 on top. 1 mole is 2.0 grams because you add up two hydrogens together. Then we're going to go from moles of H2 to moles of the substance we want. So remember, this time we're starting with each of your reactants solving for the product. So we're going to start with H2, solve for H2O. So H2O, the molar ratio is 2 to 2. Then finally, moles of H2O, grams of H2O. Hopefully you remember the molar mass of water by now because you've used it so much. 18.0 grams. All right. If you do that, you get 23.4 grams of H2O that are produced if you use your hydrogen. Let's try the oxygen. So we're going to start now with the oxygen, 10.2 grams of O2. We're going to do the same thing, solve for H2O, and see which one gives us a lower number. So grams of O2 on the bottom, moles of O2 on top. 1 mole is 32.0 grams. Next, I'm going to go from moles of O2 to moles of water. My molar ratio is 2 to 1. Next, I'll go from moles of water to grams of water. Again, 1 mole is 18.0 grams. Plug that in, you get 11.5 grams of H2O. So what does that mean? What's my answer? Is it this one? Is it this one? Is it the addition of both of them? Well, if you try to figure out how many s'mores you make, you would start with just your chocolate, your limiting reactant. So the one that's limiting you is the one that forms the least amount of s'mores, the least amount of product. So my answer is actually this one here. This is the correct answer. If you used up all your oxygen, you'd form 11.5 grams, and then the reaction stops because your oxygen runs out. You could form up to 23.4 grams of water if you used your hydrogen, but that's not possible because the oxygen runs out first after you've formed 11.5 grams. So this is your actual answer. I'm sorry that I circled the other one as well. So if you choose to do it this way on the test, make sure that you box only one of them, not the other one. So this is the correct answer. All right, please try to work on your worksheet, and I will be here tomorrow to answer all your questions. Hope you have a wonderful rest of your day. See you tomorrow.